Alright, hi everyone. In this video I'm going to show you how I made this procedural ghost shader. It's going to be more of a breakdown video, not necessarily a step-by-step, but I'll show you the general node tree, how it works, and how you can achieve a similar effect. And before we get into it, I will say this demonstration file here is available on my Patreon for second tier members and above. So if you wanted to follow along or just grab the file for yourself, you can get it from there. So yeah, recently I've been experimenting with just random things in Blender and I wanted to try giving a ghostly effect a try. And I came up with like a few different variations of the effect and I didn't really know which one was my favorite. And I should say this is an entirely procedural shader as well. So it doesn't have to use like any texture data. These are the three main variations I came up with in the end. There's one kind of like dusty one where the surface looks like it's disintegrating around the object, and then we had a couple of more wispy-like effects. We can see more of a generated pattern in this volume here, and this one I would consider more of being like a phantom of some kind, you know? So the way this is done is actually by combining two shaders. There's the principled BSDF surface shader, which is like the most common surface shader we use, and there's also the principled volume shader for getting the volume effect. So you might not have been able to tell immediately just from looking at it, but this part of the mesh, like this kind of wispy floating effect, is not actually part of the surface. It's part of the internal volume being created. And this means that this technically only really works in cycles because you can't get these custom mesh shape volumes in Eevee. But actually, just to demonstrate that, let me show you. See, we're in the cycles rendering engine over here. If I swap over to Eevee and then let the shaders calculate, then you see that we don't have that volume going on anymore. We can rotate around it like all perfectly fast in a very real-time way, and we can adjust the values for the surface shader and see those change, but there'll be no volume. So we've got to go back over to cycles to see that. Now the presence of the volume here is controlled mostly by color amps, and I'll explain that as we go. But it basically means that you'll be able to control the density of the volume as it kind of encroaches down onto different parts of the mesh. So you can get like an inconsistent density. Given that it's entirely procedural, means that you can have like all different kinds of effects with it. It also means that you can substitute generated noise textures for any pattern that you like. And there's also some kind of optional control here for using different types of like alpha masking techniques. So you can have the object fade more gradually and in a more transparent way, or you can do it how I've done it, which is where we use a greater than node to kind of clip off the pattern to give it a harsher, more disintegrated look. We'll also need to stop and take a moment to talk about the denoising at some point in this video, because the actual look of the volume is going to change significantly depending on what your denoising settings are, and that's something that's quite consistent across all cycles projects. Volumes are quite hard to interpret, especially if there are many light sources coming in from different angles, and having light sources like that is basically going to change how the volume is going to be represented in the final render, because without any lighting sources the volume can't be seen, right? That's pretty self-explanatory. And also the number of bounces we're using down in the light path settings of the rendering settings is going to adjust how the volume looks as well. So we have the transparent bounces here. If I don't have enough, then we'll start seeing black streaks coming through the volume. But we'll need to always consider the fact that this volume is inside of another mesh. So light paths technically need to pass through the mesh for us to be able to get information about the volume. Okay, so let's take a look at the nodes and see how they're actually put together. All right, so as I mentioned earlier, the actual material can be split into two different categories. We have the principled volume section over here, and then we have the principled BSDF section over here. So obviously we can see that the volume shader is here and the BSDF shader is there, and they're just being combined together in the material output node, where the volume shader is going to the volume, the BSDF is going to the surface. Easy. If you've done anything PBR related in Blender before, that's very self-explanatory. As you can see, the contents of the shader are not mixed together in any way, which means that they're completely independent effects. So you could always take these nodes and reuse them in other materials. For example, if you had any other kind of like transparent material where the inside of the mesh could be seen, you could grab these volume nodes and throw them in there and then reuse them for whatever effect you like. We'll start off with trying to describe the surface effect. So what I'll do in the meantime is just kind of tone down the volume effect a bit so we can focus on this element. Alright, so the intention behind the surface section is to be able to have this coverage control where we can basically animate the ghost-like figure appearing and disappearing and be able to basically control on a gradient, like how much of it is a physical presence and how much of it is an ethereal volumetric presence. To be able to do that, we'll basically need to be able to get a directional gradient. Now, as I said in my drawing with light video, which I recommend you watch, I'm not an expert with vector math. I tend to just experiment with things and then see what works. The first thing we'll do here is take a texture coordinate node and then grab the object coordinate, and we can actually visualize this. If I make another material output node, one thing you can do is if you have multiple material output nodes, if you click on one of them, it's going to make that the active one, and then we can plug anything into the surface volume or displacement output without needing a shader, and it will automatically interpret that data to be able to see it visually. So you can see the differences between generated, normal, UV, object, camera, window, and reflection coordinates. Here we're using object, so these coordinates are kind of like local to the object. we can rotate it around and have a look at the vector data represented as color. So basically now I have all this vector information which points in different directions around our object. I'm going to pass it through the vector rotate node, so object to the vector input. If I plug this into our surface, we'll be able to see it. And then we're going to rotate around the x-axis. That's why I have it selected. So as I rotate the angle here, you can see what's happening on the object. Now I want you to imagine that there's a kind of line going through the object. If I draw it here, kind of in this direction, pointing outwards. So as we rotate the angle, it's basically spinning that vector information around that line, if that makes sense. Maybe if I put like my 3D cursor there, set the gimbal to 3D cursor, and then kind of rotate around the x-axis there. So that's basically what's happening, but with the vector coordinates instead. So I'll leave mine on about -132. And then now that we know that we have some direction going on, what we've got to do is try and make a gradient from that. Now technically the way you do that is by just separating the x, y, and z values. So if I take that kind of vector output there, and then kind of grab the Y, plug that in, you can see that we now have a gradient going from the white to the black. If I'm rotating this, then you'll be able to see that we can rotate again the angle of that gradient. So we can use this as a mask for whatever we like. But that gradient's a bit low. How are we going to kind of control where that is? Well, that's where I have the add for the vector math node here. So all you do to make this is just go to kind of vector math, and then you can change the value to anything you like. But at the moment it's on add by default. So we plug that vector in, and then we can add to the values in the X, Y, and Z direction. So if I plug that into our material output so we can preview this, you'll see that as I'm adjusting the Y value, which is the middle one, because if you think of this as like X, Y, and Z, so 1, 2, 3, X, Y, Z, then we're essentially adding or subtracting from the Y vector there. So we're moving the gradient up and down. And again, like I said, we can kind of rotate the angle that that gradient point starts from. Okay, that's fine. So the next thing we do is we're going to disrupt this gradient with a noise texture. Okay, so we're not actually going to grab our Y value until later on. You totally could if you wanted to kind of have this beforehand and kind of make the effect however you like, but that's not how I've done it here. You'll see that the next thing I'm doing here is bringing in some randomly generated information through the use of the noise texture nodes. You can have these on 2D or 3D. It doesn't really matter. 2D is a bit more efficient, but it depends kind of what angles you're going to be looking at the object from. But notice that I'm doing something a bit strange here. I'm taking our original vector data that we've shifted using the add, and I'm using that as the vector input for the generated noise texture, but I'm also using that vector data as a base in this mix RGB node, and then combining it with our generated noise texture again using the linear light method. And then after that, that's when I'm separating the XYZ values and then grabbing the gradient. So if I shift this up and down, you can see how this works. So basically the idea behind this is just to disrupt that gradient. Now again, like I said, you can do this any number of ways. You could have separated the X, Y, and Z beforehand and then kind of subtracted a generated mask from that gradient. It doesn't actually really matter so much. That's just the way I've done it. So you can see that we now have a disrupted gradient, and we can again adjust like these values however we like. So we can add some extra roughness to give it some more noise. It's same with the detail as well. Same with the scale of the pattern and the distortion. Okay, I'm going to adjust that gradient now so that goes down. Okay, so we've now covered this section of our nodes. So what in the world is all of this for? Okay, let me bring our material output node back again. So you can see that we have a separate section down here where we're making extra nodes and then subtracting what we're creating from our original gradient here. And the result of this will end up being something much more disruptive like this, and a bit more noisy and random and a bit more wavy. So basically, just to explain that, what we're doing is we're grabbing a gradient, which is a bit randomized. So again, if I pull that vector up, it's randomized there. And we're going to create a more wavy noise texture, which when subtracted is going to create something more disruptive like this. So I'm plugging an object vector coordinate into this noise texture to have a look at that. We can see that here. If I zoom in, you can just about see the random noise there. Then what I'm doing is, because I want a slider here, which allows me to change the coverage, I'm then multiplying that noise texture by this value. So if I just take the coverage value alone and plug that in here to multiply against the noise texture, you see that as I'm going in a positive direction, it's increasing the value of that texture. If I go in the negative direction, it's decreasing the value. And somewhere in between, we can just about see the pattern in there. So at the moment, with this coverage value, if I'm increasing it, we're actually reducing the coverage. And if I decrease it, we're increasing the coverage, which doesn't make sense. So that's why I've passed this value through a multiply node. I multiplied it by -1, so it basically reverses what's happening. So I plug that value in here. Then if I adjust this value again, now as we decrease, it's reducing, increase, it's increasing the coverage. So that makes more sense. Okay, I've selected the final material output over here so we can see the final result in the 3D view. The add node is not essential. It's basically just like a buffer value if you want to think about it that way. You don't really need it, but if you don't use it, we'll just have to kind of adjust the coverage value again until we get some right values. I think the reason I used it before was to stop the result from looking so harsh. So you see that we've got quite a harsh cutoff here. I think I just added the add node to make things a bit more flaky. So that's how I've got it. You can experiment and play around and see if you'll actually need it. But in the end, this is how we've created our general pattern for the surface effect. And now we've got that pattern, we can do different things with it. So first of all, we want to make part of the object that doesn't have that pattern invisible. So the way we do that is naturally by passing the value down into the alpha of the principled BSDF shader. So if I pass that down just by itself, we have our noise textures, our pattern basically coming down the object here, following the gradient that we created, that again we can shift with that kind of vector add value. And basically the bottom of the object is disappearing because alpha is all about transparency. Now this is one type of effect you can use, a more phantom-like, regular transparent fading into nothing. But if you want to make the effect more harsh, then you can use a greater than node. And the greater than node basically says anything above the threshold will keep, and then anything below that will just make black. There's also a less than value. It's basically a way of kind of clamping or cutting things off at a threshold. So if I plug that greater than in, you'll see that instead of this progressive fade, we now have a harsher cutoff following the pattern of the generated noise, and we can adjust the greater than threshold here, and this will also shift its position. But we don't typically want to touch that. Okay, I just deleted my other material output node because we won't need it now. So we have the transparency going on, but now we can play with the color. So again, we take our pattern from the math node here set to subtract. We can then pass it through a mix RGB node, and I'm going to mix it with a color. So we can drag this back and forth. At 0, it's perfectly white, which might be your traditional bedsheet ghost. And then at a value of 1, it's entirely color 2. So we can change that to anything we like if you want to start playing with color. And then the next bit is we're taking ambient occlusion, the ambient occlusion node, which is just about shadowing the object, passing that through a color ramp to restrict the values, so where the shadowing should occur. And then we're using a mix RGB node set to darken our new color output. So we can adjust a factor on this as well. So no shadowing, completely adding the shadowing. So find a space in between where you like. And that is our first part of the shader. So by adjusting our coverage value here, if I hold down shift and click and drag, we can adjust the values in smaller increments. We now have a coverage top to bottom of this object. And technically we could animate it by right clicking and inserting a keyframe on the timeline. So by doing this, we can make an object now appear and disappear. And if I turn on the denoising, this might be easier to see. There we go. So no object, and then we can increase the coverage to have it creep down, and then our phantom is appearing. Okay, so that's part 1 of the material. Now we have to deal with the internal volume. If you've done any kind of procedural shader stuff before, this should be quite self-explanatory. What I'm going to do is reduce the coverage so we just have the volume, and I might turn the denoising off so we can see it in its raw form to start with. So essentially we have 3 things going on. We're grabbing a gradient again. This is another kind of shortcut way to get a gradient. We're using the generated object coordinates now instead. So if I make my material output node, use the same technique, generated coordinate, separate the XYZ value, take the Z value, and if we take a look at this now in the 3D scene, we have the white to black on the Z. We're not rotating it, I'm just using it like this because I know I'm not going to be rotating the volume angle. Then we're taking that Z gradient, we're passing it through a color ramp. So now if you look at this color ramp, you can imagine it like this. This end of the ramp is this end of the object. If I turn my viewport annotations on, let me get rid of that one. And then this right end of the color ramp is basically the top. So if we look at these handles here, 1, 2, 3, 4, you might think, okay, well, that's handle 1, that's handle 2, 3, and 4, or something along those lines. 3 might be a little bit higher. Okay, let me bring my material output over and plug the color in so we can actually see that represented. Okay, so you see how number 1 is black? If I move that forwards and backwards, we can see how that's moving in the 3D view. As it's coming closer up to that second handle there, it's pinching, and you can see that pinching represented by the gradient between those 2 handles becoming tighter in the 3D view, right? And we can like move the handles over and that's all fine. So that's a very visual representation of what's going on. This is basically becoming our transparency mask for the volume. So the brighter the value is, the more the volume is going to be present. So it makes sense in this case that the higher or the brighter values are at the top of the object, and that's because that's where our coverage is going to be coming from. So if I click on this handle and make that brighter, then we're kind of customizing our gradient mask here. Okay, that's fine, but I'm going to make it a bit more subtle for now. So you can think about this as section 1 if you want to. This is basically our transparency gradient. Let me remove my annotations. Okay, so the next section is we're making another kind of randomized generated texture. If I plug the result of the color ramp in, you can see what's going on. And this one's very streaky. So this was to try and get that kind of falling dust-like effect by having some inconsistent lines. So it's like the dust is kind of disintegrating down. Again, taking a look over at some of the final images, you can see this represented here by there being like a thicker section of dust there, like another thicker section there, and it's kind of inconsistently streaky. So that's what we're getting over here in the nodes. And the way this is done is by taking that generated vector coordinate in the mapping, stretching it with the X value on the scale here. So if I drag that backwards and forwards, we can kind of stretch that out. And then with the Z value, it would be 1 traditionally. We can make that 0 to stretch out even more, or do it kind of in any direction we like. So you can play with these values and make them as tightly packed as you want them to be, but then passing that as the vector input to the Voronoi texture, so we can increase or decrease the scale, smoothness, randomness, and anything like that. And then again, we're using a color ramp to restrict the values, so we can bring the black and white closer together. And then what we're doing is we're taking our transparency mask that we've created up here in the color ramp, and we're now darkening it with these streaky Voronoi lines. So the result looks like this on the object. All right, let's drag this out. So that's section 1 and section 2 done now. So we've got our transparency and our streaks. But that by itself is kind of cool, but not really enough for like our 3-dimensional volume. So that's why we have one more noise texture being generated here. If you take a look at the output for that, it's patchy. And again, we're doing the same thing. We're using a mix RGB node to darken the previous result. All right, so transparency is now darkened by the streaks, and now the streaks are darkened by the patchiness. And then if we bring that output, we can see this. So we now have our transparency, which we can control, our streaks, which we can control, and our patchiness, which we can also control. The final result of that is now pushed to a math node, which we can multiply, and that becomes the density value for the volume. So if we go and take a look now, this is the result. The reason why it's colored is because we have colored lighting in the scene, and when a volume is pure white, it's going to adopt the color of the light that's affecting it. We could change this by changing the color value here, and that will basically restrict the color of the volume, so you can get creative with that if you like, but we're going to leave that on white. So now putting this together, if I bring my coverage for the surface shader back up, then you can start to see how these come together. So at this value, you can start to see our surface effect creeping down the object, and the volume is included inside. Now, the volume result will look different depending on whether denoising is active. As we alluded to earlier, noisy volumetric data is quite difficult for the denoising to interpret because it's going to be very flickery. There are going to be some very bright pixels and some very unbright or dark pixels. So you might sometimes end up with like a sparkly effect going on. And that might actually be what you want. So you can get kind of creative with these imperfect results created from the denoising process. As we can kind of see here, it looks almost like a star field. So that could be mitigated by increasing the number of samples. Obviously, the more samples you use, the more accurate the volume is going to be. But maybe you might want to take advantage of that star field effect by not using so many samples. But just to illustrate the kind of creative control we have here, now if we go back to our volume transparency gradient, if I want to say make more of this statue's body visible in the volume, all I would need to do is increase the brightness of this gradient here. So if I go back and increase these values, now you can see that more of that object is being shown. You need to be quite careful with these though, because you just want to be very subtle with the brightness on these. So if I make these, again, a bit more subtle, maybe bring the black gradient downwards, bring that down a bit more, then see that we're getting more of the statue kind of being visible there. Now again, about the denoising, those kind of fireflies will look quite strong and bright to start with, but as more and more samples resolve and the denoising takes over, they kind of settle back down a bit. So you've got to be aware of that curve of intensity before the more accurate data comes in. So maybe let me increase that a bit more and we can try doing a render of some kind. All right, let's try a render at like 100 samples and just see what happens. Okay, so there we go. This render is done, but this isn't actually what the render came out like, and I'll explain because I have some compositor nodes going on. Okay, so it's time to give you a little denoising compositing trick. So the actual render result is this. And we've got lots of fireflies. Now 100 samples is not much for a general volume render like this, especially with 1, 2, 3, 4, 5 area lights affecting the object. But the reason why I've left it so noisy like this is to give you a demonstration of this next tip. So if you're in the compositor nodes, there's the denoise node, which you can use to denoise the result. And the immediate result of the denoising will look like this. So it's okay, but it's very smooth. It's quite painterly. Maybe this is what you want. Okay, so maybe you want a completely smooth and completely denoised result. But if you don't, if you want something in between, then if you use a mix node, plug the original render into image 1, and then plug the denoised version into image 2, and then plug that into the result. And then what you technically have here is a mix value where you can blend between the original render and the denoised version until you get the result that you like. So basically, if you wanted, you could find like a 3/4 value like this, where you are withholding some of that grain, some of those firefly effects inside of the smooth result. So again, for artistic effect, if you wanted to, you can keep some of that data in there. Okay, so what if I want to make this a bit more pretty? I look at this and I think that value is a bit bright for like the kind of color of the statue. So maybe I'm going to make that a bit more representative of the color of the volume. Can make it a bit darker as well. That might be all right. Let's bring that up a bit. I'm going to try and bring the brighter side of the volume gradient closer to where the actual surface is disappearing to try and make it a bit thicker in there. However, I might also try plugging the color down into the color value of the principled volume. Is that going to do much for us? Will we need to increase the volume after that fact because it's so much darker now? I wonder. No, I think that ruins the density. So sometimes in our tutorials we do bits where we try and improvise at the end just to kind of like demonstrate how it might be used. But I'm kind of interested in the idea of adopting some of the color from before. Maybe I'll just try and do it manually down here. Do like a slightly brighter version, not too much color, just a bit. It's interesting, I think because of the lighting, the simple color of the volume here is amplified so much in the scene. So I'm going to try and make these a bit whiter. Okay, I'm also going to try turning off a bunch of the lights because I might as well just demonstrate to you how much of an effect the lighting can have over the volume. So if I leave it so maybe there's just one light on. Oh yeah, that's a good one. So here you can see that the light is coming from the back. And because of that, it's filtering through the volume a lot more, so the effect is very, very present. But if I swap this light over to something else, like this one now coming over from the side here at quite a distance, it's not really filtering through the volume as much, so it's not so obvious. And then again, maybe for a final demonstration, if I increase my HDRI value, that is kind of filtering through the volume, but it's so slow because there's so much light and color data coming in from like every direction. So I don't recommend using HDRI lighting with an effect like this. And now maybe one more thing I'll show you is that because this is a simplified version of my original artwork, I'll just give you a quick look at some of the original files because it will also show you how to get some of these extra kind of mucky effects going over the surface. Okay, so here's one of the actual art files. And this one takes quite a while to resolve, even with denoising on, because there's just so much bounce lighting going on. We've got a light catcher active as well, so if you turn that off, it should speed things up a bit. Not all of the lights are active, but we'll have to make do with this. If you take a look at the nodes, you'll see that they're not actually exactly the same as what I showed you. That's because a lot of that pattern building for getting the coverage over the object is actually controlled by this node group here called streaks. It's a node group I was working on, but the name doesn't actually make much sense for it anymore. So I can control the coverage with this coverage value. So it's a bit difficult to see because the object disappears and then reappears. But then the color information, so the actual surface information and normal information, is generated with the ambient grunge node, which is one of my products for getting like procedural grunge and dirt effects over objects. And the roughness is given by the complex iron node, which is again part of one of my paid products, the modular metals pack. I love using it for getting like randomized reflectivity effects and stuff like that. So the combination of all these effects makes something much more complex. And it also gives us control for things like edge wear across like very harsh angled areas of the mesh. So we can change that with like these edge wear radius values and stuff like that. So that's where the actual like textured surface pattern comes from. Now again, like these products mentioned are available to get on Gumroad and Blender Market. They're available on my website, codesholt.online/store, and places like that if you want to check them out. I also use some nodes like the get edges node over here for getting like edge masks. So if I plug that into the surface, I wonder if I can help with that. Yeah, so you can use this data for like curvature and stuff like that. This get edges node is actually part of a free pack I have called my node group tools if you want to make use of that, because you can use that for all different kinds of effects as well. If you want to simplify the process of getting ambient occlusion as well, I have a get AO node, which does pretty much the same thing if I plug that in. So yeah, so you can get your ambient occlusion like that. So anyway, like I said, this simplified demonstration file is available on my Patreon for second tier members and above. I hope you found this video interesting. I hope you've learned something from it. If you want to learn more about Blender, how to improve your artwork, or some other cool techniques, And even if you want to see other things happening in the community, you can check out my other videos on this channel. Maybe join our Discord server to take part in discussions, art challenges, share your work. I've got a bunch of other resources and tools, both free and paid, on my website. Again, codeassault.online/store. And if you want to help me contribute to the Blender and wider CG community, you can either sign up to the Patreon or use a new super thanks, which we've enabled on this channel, which is basically where I think like if you donate a certain amount, you can get like a colored highlight by your comment. And depending on how much you donate, that will change the color of the highlight by the message. I'm not too sure, I've never used it before, but maybe someone can give it a try. And there's one thing we do on my channel where if you make it to the end of the video, I give you an emoji to put in the comments so I can see who made it this far. So the emoji for this video is, well, what else would it be? It's a ghost. So if you put Casper the Friendly Ghost down below, I'll be able to see who actually made it. So thanks for watching everyone, have a fantastic day, happy blending, and I will see you next time.